just a few words about me. So my name is Silvia da Graça Ramos. I have a very different background from most of the people in this workshop. So I did a PhD in fusion, nuclear fusion. Previously I was a researcher. So I have a background on physics engineering and electrical and computing engineering. So as a researcher, I set up diagnostics, a lot of instrumentation work, data analysis work, and I also obviously do some publications. So I work on all the research life cycle. More recently, in the last 7 years, I've been working at Diamond. First in the data acquisition group, developing data acquisition system for our beamlines. And in the last 5 years, I've been working as a software engineer for data management. And I'm more focused on the Diamond Data Archive. So first of all, so just a small presentation of Diamond Light Source. So Diamond Light Source is a UK national cyclotron. So it has an electron energy that is medium, the 3 giga-electron volt. So concerning the number of beamlines, we have officially 33 instruments, but this is the number of beamlines. Some beamlines might have some end stations. So in terms of end station, that would be probably 43, plus some laboratory like LabXChem, for example. We have more recently, since 2016, electron microscopes as well. So we have the Electron Bioimaging Center, EBIC, that contains now 10 electron microscopes. And more recently, the Electron Physical Science Imaging Center with 2 physical electron microscopes. We also have some data coming from X-FELS, the electron laser in Hamburg. So here, this is the photon and neutron research life cycle. So photon and neutron called PAN. So, well, this is specific to PAN, but I believe can be applied in a large number of large facilities. So here I tried to, this is a very simplified research life cycle, and I tried to match how data management systems with the various phases of this cycle. First of all, so we have a proposal system. So a user, when they decide to come on site to perform an experiment, will submit a proposal. Then this will be reviewed by a review panel and eventually accepted. And then the experiment will be scheduled. So we'll have a so-called some 1 or more sessions in a beamline or electron microscope. So for the proposal approval and scheduling, users will be in contact with our user administration system to perform all these tasks. Then they can, at Diamond, users can perform the experiment either remotely or on site. Well, at the moment with the pandemic, we have a large number of remote experiments. So they come on site, and on site they will be using iSpy-B, which is our information system for protein crystallography beamline. Data will be mainly written using a Nexus format and HDF, which is trying to have this as a standard. So the data processing pipeline at Diamond will generally write a Nexus files, but our beamline can have multiple formats. So we will be able to produce Nexus file, but also format that is being used by the research community. The next step will be the data preservation and data curation with ICAT, which Alejandra described during the first talk in this session. And ultimately, we will have the publication. So this will be recorded in our PubMed, our publication system. So I will go through all this system to describe a little bit more, give more information about the system. So here is the user interface for the user administration system. So, for the data catalog perspective or for data preservation, we mainly take information about the proposal title and summary, but the experimental team, the proposal and session user, is quite valuable information for a data catalog. So this includes the full name, the role in the experimental team, like principal investigator, affiliations, and OKIT, which is mandatory for principal investigator in a proposal. Then we will also get some sample information that are introduced in the UIS system for health and safety consideration before the experiment. So here you can, I just provided a link for how users can apply for beam time at Diamond Light Source. There are different routes, like standard, like BAG, which is a block allocation group, rapid access, or long-term access. So here is a user interface of the iSpy-B system. So this is used for sample shipment. It is mainly a laboratory information management system that is being used during the experiment. This system is fully integrated with our generic data acquisition software called GDA, but also with our data processing pipeline. So here you can see a screenshot from one of the COVID experiments, and this experiment is now available in Zenodo. So here you can have information about the sample, some processing information, so you can have some logs from the processing pipelines. So that could help users to perform and manage the experiment on site. So this system is very mature for the MX community because it has initially been developed in this community, but we are now trying to roll out across more beamline and in order to facilitate experiment, especially remote experiments. So in terms of file format, so in the photon and neutron community, we use a data format called Nexus. This is an example how Nexus looks like on the right-hand side. So this gives information. So what we call metadata in Nexus, so the data would be the data produced by the detector, and this will be a HDFI file. And this Nexus file will be a file, and we have links to the HDFI file produced by the detectors. So this HDFI file produced by the detector can be produced by the data acquisition software or by EPICS, which is our control system, especially for area detector. So this format was initially developed for data processing interoperability, to allow interoperability for software. But now we are starting to use it as a standard for data catalog. Recently, with the Expense project that Abigail and Alejandra already described, so this Nexus has a format called NXDL, which is very pan-specific, and we tried to convert it to a more to a null format, which can be used across communities. And we also added some PIDs, persistent identifier, for the Nexus terms that will allow interoperability between our data catalogs. So so we are just waiting for the NIAL, which is a Nexus International Advisory Committee, to be accepted, but we already have the Nexus repository, so it's just a question of time. So concerning Nexus, this is being used, as we see here, by around 80% of our beamlines. For the electron microscope, we don't use Nexus. This community use mainly MRC format as a standard, so we will keep this the MRC format. So for information, this Nexus file is currently archived in ICAT. So we can, when we are downloading the Nexus file, we can have all the metadata related to the experiment. So the metadata could be position of motors, sample temperature, program used to create the file. So all this information is there. Now concerning the ICAT data catalog. So the data archive is located at Scientific Computing Department, the SED. And we have a service level agreement with them for the operation and also for the development of some software tools. So as you can see on the right-hand side, we have around, at the moment, the exact number will be 28.5 petabytes as for 2 days ago. We have more than 3 billion files in our data archive. So just to give an idea, we can have a beamline with just a few gigabytes of data, while other beamline will produce a few terabytes of data during a session. So we keep, so in our data policy, we guarantee that we, for now, we will be, users will be able to access data within 30 days after the visit or after the session. So currently it's 40 days, but this can be reduced. For small data set, we will recommend to use FTP, SFTP or rsync. And for larger data set, we would recommend to use Globus Online. So in here, for the Globus Online, ideally, if your university or department could install an instance of the Globus Online for your use, will be better because it can have a better setup, a better network, especially for large amount of data. And especially for industrial users, the AWS CLI tool is quite popular as well. So just another information is that our data during the session, we transfer the raw data to our data archive to ensure a second copy of the data during the experiment. So after the experiment, so we can, especially after the 30 days, users will be able to use ICAT to access the data on tape. So currently we have only one copy of the data on tape. So we recommend users during the experiment to back up the data on our drive using our data dispenser, or to, if possible, to use a Globus Online. Otherwise, they can access the data using, for example, HTTPS, Globus Online. They can transfer data to the SCARF cluster at STFC, UKRI, but also restore data to the high performance and parallel file system GPFS available in our facility. Finally, Concerning the publication, so that's the last step of this research life cycle. So users will be able to do the experiment, have some process data when they leave the facility, and then they'll be analyzing more deeply the data, and hopefully we'll be able to produce a publication. So this publication system is supported by the Communication and Business Application Group. So recently, due to the open access policy, which is a recommendation from the EU, so we have some policy that can be accessed through this link. We recommend our users to write this following acknowledgement. That will help us to search and link publication with our database. And we also recommend users to provide a copy or information about their publication when using data from Diamond. So more information is in this link. So there is still a lot to do. So we are starting to, as a previous presenter said, trying to understand which metadata would be important and useful for a data catalog, because with 28 petabytes, with a tendency of growth, especially with with Diamond 2, so it's very important that people is able to find the data. So adding more metadata will make this the data more findable, especially when the data is on tape and not easily accessible. So so from the UIS, we are trying to work on the ROI for affiliation. Abigail mentioned this. This is ROI, our persistent identifiers for affiliation. We are trying to propagate information about the funding agencies that is used during the proposal, but also the disciplines that are introduced by the user when they do their proposal on the UIS system. So, so concerning iSpy-B, we are trying to roll out across more physical beamlines and electron microscopes, so that they can have good functionality and facilitate the running of the experiment. We are trying to understand which metadata could be useful to link with our data catalog, especially information about the sample itself. Concerning Nexus, at the moment there is not a standardization. So we have some project trying to standardize how metadata is written in the Nexus file and trying to roll out across all the beamline. And this can be used as a metadata standard also for data catalog and fairness, as I mentioned previously. Publication, so working with publication, so with a communication team that are very interested on linking the data publication with a journal publication. So here, being able to mint a digital object identifier for our data. We still have some work to do about understanding if you should have a DOI for each session, or user just select data that they want to make public. Currently, our data are made public through Zenodo, but Zenodo still have some limitation in terms of size. In terms of post-experiment data processing, we are exploring Iris for post-processing. That is an open stack at SCD that is linked with the data analysis as a service that was mentioned before. And finally, we are working on our open data policy. So here is a link with the current open data policy. And just to answer a question that some of our attendees asked before, in 2019, we changed our data policy, and it says that data may be made open after 3 years. So it's still maybe. We are still working on updating this data policy with more detail, working on meeting DOI, as I mentioned, as part of the expense project, trying to harvest metadata to other data repository. And finally, I would like to say, if any of you that are the user of Diamond, if you have some open data use cases, please contact the Diamond Comms. We are now trying to work with our user communities and in order to understand their requirements for open data. So thank you very much for your attention.